So week 5, or chapter 5 especially, is a major one here for us for the Statistics 1 course. And this is the first time we are using the normal curve to help us make predictions or answer questions about a certain distribution. I'm going to walk through items number 5.12 and 5.14 from the text as a sample to help you with your assignment and also, more importantly, the overall idea of what's going on here. So for this example, the context was the lifespan of light bulbs. And these certain light bulbs, a key term within the directions are the fact that they are approximately normally distributed, or the curve itself is approximately a normal curve. That is the cue for allowing us to use the normal distribution as a model to answer questions here. So for this first problem, the mean number of hours for the lifespan of the light bulbs is 1,200 hours or 1,200 hours, and the standard deviation is 120. First thing I want to do is, and good practice, even if it's not part of what you hand in for the assignments, is to sketch a normal curve to get a sense of what this looks like. I do believe, and even now with more years experience of doing this, I still like basically the safety net of sketching this so that I know I'm at least on the right track. So I have a normal curve. Looks like your typical bell-shaped curve, but again, this is very specific now, being a normal curve. And I like to make increments where you have the mean in the middle, and I like to go down 3 units to the left and up 3 units to the right. These allocate the number of z-scores we are away from the mean. So for this problem, or the set of problems, 1200 is going to be our mean. And again, our standard deviation, I'm going to write on the side here, is 120. So each one of these tick marks represents 120 more hours, either above or below the mean. But what we want to do is end up converting this to z-scores, which then represents the standard normal curve, where the standard normal curve, I'll put it in green, has z-scores of 0 at the mean, and 1, 2, 3, -1, -2, -3. This allows us to use the table, or table A, in the back of the book. So for this first problem, question is, what proportion of the population can we expect to have less than, or light bulbs last less than 960 hours? So 1200 is right here at the mean, and 960 is less than that. The question is, how far less? So the first thing we want to do is use the formula for the z-score, and that is to take the value that you have, in this case it's x, or 960, subtract from it the mean, and then take that answer and divide by the standard deviation. This is going to give you your z-score, or where you fall on this table. So for this problem here, z-score of 960, I put in 960 minus the 1200, which is the mean, divided by 120. Now, if you're using a calculator here, I highly recommend that you put parentheses around the 960 and the 1200, because when you divide by 120, if you do not do that, it's only going to divide the 1200 divided by 120. So the order of operations is important here. And this ends up being a z-score of negative 2.00. So that tells us then that for this problem, and I'll use red here to sketch it, they're asking us what is the proportion of the population that falls below this, or less than negative 2.00. So I need the area under the curve here. And that area under the curve represents the proportion of the population. So then I use table A, and I scroll down the left column all the way to 2.00. Now remember that that table is set up so that you only have positive z-scores. Right? So in the table, you're technically looking up, you're technically looking up this piece right here. and looking up the area from positive 2.00 to the tail. That is the same as the area from negative 2.00 to the left. So when I look up that value, I get, in this case, it gives you a value of 0.0228. Okay? Which coincides with, and some of you might be more comfortable with percentages, that means that 2.28% of the population falls below 2 standard deviations of the mean. Or in this case, we can expect 2.28% of all the light bulbs to last less than 960 hours. But it's not a bad idea either, though, at the same time, to just stick with proportions. Think of the proportions of the population. The entire population represents a proportion of 1.0228 is a very small proportion here. Next problem. Let's try to find the proportion of light bulbs we can expect to last longer than 1500. So 1500 is greater than the 1200, but again, we need to find the z-score. So I'm going to go z of 1500. It's going to equal 1500 minus 1200. Find that value, then divide by 120, which is our standard deviation. And that gives you a z-score of 3.33. Pardon me, I accidentally had 1600 down. 1500 is the question here. And so we end up with a z-score of a positive 2.50. And what I'm going to do now is real quick erase this blue. So for this problem, we're looking, what is the area under the curve from a positive 2.50 and to the right? Because we're looking for the proportion of the population that's going to be more than 1500. So when I look on the table A, and I go and find on the left column 2.50, I want to then look under the column that coincides with the area towards the tail. And in this case, then, we get a proportion of 0.0062. Again, a small group. And hopefully it starts making sense that this is actually a little smaller. We're a little further out towards the tail than we were here at -2. So the area under this curve, or this portion of the curve, should be less than we had for part A. For part C, we're looking for within 50 hours of the mean. So I'm going to sketch another normal curve here real quick. And again, it can be crude like that, nothing wrong. So 1200 again is our mean. And we're looking for what is the proportion of the population is going to be within 50 hours of the mean, which means I need to go 50 hours above to 1250 and 50 hours below to 1150. Now I want to find the area under the curve between these two values. What we need now again is to go back and find the z-score. Realize that the bell-shaped standard normal curve is symmetrical. So we technically only need to find a z-score for one of these. So I'm going to find a z-score for 1250. So 1250 minus 1200, all right, gives us that value of 50 above, divided by the 120. And that gives us a z-score of 0.4166, the 6 repeated. What we're going to do now is just round this to 0.42. So that is the z-score where we fall in the normal curve. Look in the back in table A, and we can see that the area under the curve from 0.42 z-score to the middle is 0.1628. This is giving us the area from 1250 to 1200. We just found the proportion of the population, or the area under the curve, for that segment. Realize then from 1150 to 1200, since this is symmetrical, is going to be the same value. So they were just going to multiply this by 2 to get a total of 0.3258. I'm sorry, 56. So that then gives us the answer for part C. I'm going to move on to item number 5.14, because this problem is having us work in the reverse order of 5.12. So the first one is more, part A is more of a test to get a sense, do you understand the normal curve in general? And again, this is the same context of the light bulbs, normally distributed with a mean of 1200 and a standard deviation of 120. So each one of these increments, or each z-score going above or below, represents 120 hours. This problem, though, is asking us what is the value or the length of the lifespan of a light bulb in which that it falls, that the area under the curve, or the population, 50% is above that value. So understanding the normal curve and the fact that it's symmetrical, at this point hopefully you realize that the area to the right is 0.50 and the area to the left is 0.50. So for part A, it's more testing an overall understanding that if I am actually at the value or lifespan of 1200 hours, I can expect that the upper 50% of all the light bulbs will fall at that number of hours or above. However, this problem now, the lower 75%. What they're working on here and want us to figure out is, if I have a normal curve again, I want to find out the lifespan or the life of a light bulb such that, or the number of hours such that, the lower 75% of all light bulbs fall in that window. So picture having 0% here, 100% at the very top tail. I want to find out where that lower 75% lie. Well, if 50% fall to the left of the mean of 1200, then I need to be at a marking above the mean such that the area from here all the way to the left is 75% or 0.75. Now, if I know that 0.5 or 50% is the value from the mean to the left, and I want to find out where the total area is 0.75, then that leaves me 0.25 as the area from this value to the mean. So I'm going to use table A, and instead of looking up the z-score, I'm looking for the actual value of 0.25 as the area under the curve from a certain point to the mean. And if I scroll down, you'll see that there is no exact 2.500. However, there is a 0.2486, and just below that, 0.2517. And for what we have here on the table, we're going to look at which one is closer. And this value ends up being closer to 0.2500. And the z-score for that value is 0.67. That then is the area, or the z-score here, 0.67. So I then need to find the value of what the length of the light bulb is there. So in this case, I need to find the mean, which is 1200.